Bismillah, alhamdulillah, salatu wassalamu ala rasulillah. Section B3 is about exponents, integer exponents, and scientific notation. After completing this section, you will be able, inshallah, to use the exponential notation, simplify expression by using the laws of exponents, which is the main part of this section. And also be able, inshallah, to write numbers using scientific notation. We will see together what is this. First of all, of course, you need to remember the exponential notation. I have introduced this for you in section B2 already. So what we mean by the nth power of a here is any real number. It is just this number multiplied by itself n times. So when we have a to the power n, we have n factors of a. The base is a, n is called the exponent or the power. A half to the power 5, it is just a half multiplied by itself 5 times. Negative 3 to the power 4, it is negative 3 multiplied by itself 4 times. Negative here, negative 3, it is in the base. So the base here is negative 3. But here the base is 3. So this number is positive, but this number will be negative. And what is repeated here is 3. So it will be 3 multiplied by itself 4 times. So we will have at the end negative 81. I mentioned this common mistake here. So be careful when you deal with such quantities. Just ask yourself, what is the base that you are applying the exponent for? Look at this. When we have 5 to the power 4 times 5 to the power 2, you have here 4 factors of 5 and 2 factors of 2. So you have 5 to the power 6. Indeed, from where this 6 is coming, it is just 4 plus 2. In general, when you have a times a to the power m multiplied by a to the power n, it is just a to the power m plus n. This says that when you multiply two powers with the same base, just add the exponents. Now, it is clear with that a to the power 1, it is a. We don't write the 1. When we have a squared, it is a times a times a. When we have a to the power 3, it is a to the power 3, a to the power 3, a to the power 3, and so on. Now, what is a to the power 0? Yes, a to the power 0 is 1. Why is that? Why it is 1? To understand that, let me introduce to you, we will use this fact that a to the power m times a to the power n, it is a to the power m plus n. So let's think about specific number. Let's say a to the power 0 times a to the power n. In general, this is a to the power 0 plus n. Just we bought m equals to 0. So this will be equals to what? A to the power 0 times a to the power n, it is a to the power 0 plus n is n. So what is the number if you multiply it by x? X times what? X times what? To be equals to x. If you look at this, it is what? It is 1. X times 1 equals to x. So here we have, this is our x here. A to the power n times what equals to a to itself? It is 1. This will show you that a to the power 0 is 1. Just divide both sides by a to the power n if you want to look at it. Cancel. A to the power 0 equals to 1. There is another way to show you by using the quotient instead of the multiplication. I provided you here with the specific example. 2 to the power 0 times 8, it is equals to 8 at the end, because 2 to the power 3 it is 8. So it is 1. This suggests that 2 to the power 0 is 1. And this, of course, make everything consistent when we deal with powers and exponents. Similarly, I think you are aware that a to the power negative 1, it is just what? 1 over a. Similarly, a to the power negative 2, it is 1 over a squared. So in general, a to the power negative n, it is 1 over a to the power n, which means that when you raise a real number to a negative exponent, it is just the reciprocal. Why is that? You should, of course, ask yourself. So you should ask yourself this question: from where this is coming? If you use the same idea, let's say a to the power negative n times a to the power n. This is a to the power negative n plus n, which will be a to the power 0, which is what? 1. So this says that a to the power negative n times a to the power n equals to 1. So when you have x times what? X times what equals to 1? It is equals to the multiplicative inverse. So this means here, this question mark is the multiplicative inverse, which is 1 over x. So now what is the number that if we multiply it by a to the power n, we will get 1? A to the power n times what? To be equals to 1. It is times to its reciprocal. Now this a to the power n will be cancelled with this a to the power n, and you will get 1. So because of that, a to the power negative n, it is equals to it does the same job. It is the reciprocal, it's reciprocal of a to the power negative n, the same. They are just reciprocal of each other. So according to that, 4 over 7 all to the power 0, it is 1, because a to the power 0 is 1. X to the power negative 1, it is 1 over x to the power 1, which is 1 over x. X is not 0, of course, here. Negative 3 to the power negative 3. So this is important, Shabab, because it is a common mistake also. When you have here just a, you would use this rule. I know that one student, he said that this is equals to negative 8. Is it correct? This is not. 2 to the power negative 3, it is 1 over 2 to the power 3. It is 1 over 8. Here we have negative 2 to the power negative 3, so it will be the reciprocal of 2 to the power 3. So just here, this the power n is 3 and a is negative 2. Now negative 2 to the power 3, it is negative 2 times negative 2 times negative 2, which will be negative 8. Never ever, don't write about the sign, the negative sign in the denominator. Write it in the front of the fraction, or in the numerator, but not in the denominator. It will cause a lot of troubles. Again, here this is additional exercises about how to deal with the negative when it is the base or not. 4 to the power 0 is 1. Negative 4 all to the power 0, it is also 1. Any a other than 0 to the power 0, it is 1. Negative 4 to the power 0, here the base is 4, not negative 4. So negative will be alone. Here the negative is just negative 1 multiplied by 4 to the power 0. Negative 1 multiplied by 1, it is negative 1. Similarly here, negative 4 to the power 0, this is 1. 1 multiplied by negative 1, it will be negative 1. Excellent. Now, this is the most important part, ya shabab, the laws of exponents. Here you have the law, and here you have an example about it, and this is how to describe it, how to communicate these laws in English. So what does this say? It says that to multiply 2 powers of the same base, add the exponents. Here, subtract the exponents. When you raise a power to a new power, multiply the exponents, the inner by the outer, and so on. Let me show you here this in a large scale here. So we were here. Now, what does law number 4 says? It says that if you raise the product to a power, raise each factor to that exponent. In other words, you can distribute the power or the exponent over the product, similarly over the quotient, but not over the sum and the difference. This is a very common mistake, Shabab. Please, you cannot distribute the power over the sum and the difference. In other words, if you have a power of a sum, it is not the sum of the powers. It is not just you will distribute the power for both. This is just in the case of multiplication and division. Property number 6, it says it's just a generalization for the reciprocal idea. A to the power negative n, it is 1 over a to the power n. So the same here. In fact, a over b all to the power negative n, it is just 1 over a over b all to the power n. And by law number 5, this is a to the power n over b to the power n, which will be by the reciprocal idea, ya shabab, it will be b to the power n over a to the power n. By law number 5 again, this is b over a all to the power n. No need to do this all the time. Just apply rule number 6. This shows you how we obtain law number 6. Law number 7 is the same idea. It is just a direct application for this property. When you have a, how to show it? A to the power negative n over b to the power negative m. Notice that they are not the same base here, shabab. Otherwise, it will be easier. Here we have a, here we have b. Now here it will be 1 over a to the power n all over 1 over b to the power m, which will be equals to what? 1 over a to the power n multiplied by the reciprocal, which will be b to the power m over a to the power n. So this just suggests that when you want to change the sign of the exponent from positive to negative, just of course, if they are factors, you can convert them, of course, move them from the numerator to the denominator and vice versa. These are some examples or direct applications indeed for these laws. Here you are, this is for law number 1. Just when you have the same base, just add the powers. Here add the powers. Be careful when you have negative. When you can write the negative powers in the denominator like this. You will subtract here by law number 2, subtract the powers. Here, be careful when you multiply, when you have a power raised to another power, you will multiply the inner with the outer power. Not you will add, you will multiply. When you distribute the power, don't forget to distribute it for both factors here. Similarly, in the case of quotient, simplify your answer always. Always ask yourself, Shabab, which law I'm applying. Now, this is A, this is B, different bases. We cannot do the addition because they are different. What we will do, we will try to combine the similar terms. 2 multiplied by 3, it will be 6. Here we have, of course, 3 multiplied raised to the power 3. So it will be wrong if you did that. If you just multiply 2 by 3, it is wrong because 3, it is raised to the power 3. What you should do first is not the multiplication. Simplify here if you can inside the brackets. Do the parentheses according to the order of operation. We have nothing here to simplify. So what we will do, we will move to the exponents, the power. So we will distribute this power over these 3 quantities. So what we will have, this is the same as it is. And the second factor here, we will have 3 to the power 3, a to the power 3, b to the power 4, all to the power 3. So it will be b to the power 12. According to that, this 3 to the power 3 will be 27. It will be multiplied by 2 now. Now all of them are to the power 1. And it is a matter of multiplication. 2 times 27, it will be 54. And a to the power 3 times a to the power 3 will be a to the power 6. And b to the power 2 multiplied by b to the power 12, the same basis, we will add the powers. Be careful, don't add the powers when they are different bases. Just when we have the same basis, we can add the exponents. For the second one, similarly, you will distribute the 3 over both numerator and denominator. Similarly here, you will of course look at the factors here. We have factors, not terms. We can do that. It is a direct applications for law number 4 and 5. So it will be y to the power 8, x to the power 4, z to the power 4. Now simplify. You have now x to the power 3 and x to the power 4, the same base. So it will be x to the power 7. And here you have also the same base, y over 8, y to the power 8 over y to the power 3. It will be y to the power 5. And the final answer will be x to the power 7, y to the power 5, z to the power 4. If this power, for an instant, was negative, it will go down, but it is positive. So it is important when you simplify to ask yourself, the final answer, is it in the numerator or the denominator? When you have negative exponents, how to deal with such quantity? You will use law number 6 or law number 7. You can use any one of them. It depends on the problem that you have. For instance, here, we can use law number 7 by just moving, because we have factors here, all of them are factors. Bring this down to be in the denominator, and this one up to be in the numerator. Just move them by using law number 7. Now you have here 6s times s to the power 2, it will be s to the power 3. You have 6 over 2, by the way, this one, 6 over 2, it is 3. And this will be s to the power 3. And this is t to the power 2 times t to the power 4, it will be 2 to the power 6. And this is one way. The another way, Shabab, is to do this. 6 over 2, the coefficient over the coefficient. This is s to the power 1 minus, this is in the denominator, minus -2. And here we have t to the power -4 minus, because this is in the denominator, -2. Simplify, 6 over 2 is 3. It will be s to the power what? 1 minus -2, it will be 1 plus 2, it will be 3. T to the power -4 minus 2, it will be -6. And you can write this, of course, as 3s to the power 3 all over t to the power 6 by law number 7, by the reciprocal of the negative exponent here. So it is the same. You can do it this way or this way. For part B also, you can do part B in 2 methods. One way is to apply law number 6. Here it is, this one. Apply it here. You will flip down the numerator will be denominator, and the denominator will be numerator, and change the power from positive to negative. Now it was here -2, it is here +2. So it will be 3z to the power 3 over y. Now distribute the power over the quotient and over the product. So you will have 3 to the power 2, which is 9, z to the power 6 over y to the power 2. This is one way. The another way is to distribute it from the beginning, y to the power -2, 3 to the power -2, z to the power -6. Now you will apply law number 7. You will bring this up and that down, and you will get this. Try to avoid working with negative signs, because many mistakes are coming. So dealing with positive is much easier. Now, I think now, Shabab, you are able to solve this, to simplify this expression. This is a recitation exercise number 2. Let's pause the recording, and I will give you 2 minutes to solve it. I will take the attendance during that. Please, Shabab, try to simplify your answer, and be careful when you are using law, which law you are using. You should always ask yourself about this question. Apply the laws of exponents. Excellent. Check your answer, ya Shabab. Is this the answer you obtained? Should be simplified. Okay, excellent. Let's see, ya Shabab, how can we do that? Of course, we can obtain that in several ways. Let's choose 2 ways to show them. The first way, Shabab, is to distribute the power here over each factor in the numerator and denominator here, because all of them are factors now. What we have here, it will be 2 to the power -3, a to the power -1 multiplied by -3, it will be 3. X to the power -2 times -3, it will be 6, over b to the power -2 times -3, it is 6, y to the power 3 times -3, it is -9. This is the first factor here. Now, this is a multiplication, Shabab. When you have brackets multiplied by brackets, it is a multiplication. You will have here 2 to the power 3. The power here is 3, not -3. A to the power 3, y to the power -9, all over b to the power -3, x to the power 3. Now, this is your favorite part, the cancellation. You have here y to the power -9 over y to the power -9. So you have 1 here. Similarly, you have here 2 to the power -3 will be cancelled with 2 to the power 3. Why? Because it will be 2 to the power 0. 2 to the power 0 is 1. Next, now combine the like terms, simplify the numerator and the denominator. You have a to the power 3 times a to the power 3. It is a to the power 6. x to the power 6. Okay. Now what we have in the denominator, b to the power 6 and b to the power -3, it will be b to the power 3. And we have here x to the power 3. Now you have here the same base, so you can simplify. A, there is no more a's, it is only this one. Also no more b's, it is just this one. Now this will be x to the power 6 over x to the power 3, so it will be x to the power 6 minus 3, it will be 3 in the numerator. If it was like this, ya shabab, it will be in the denominator. Okay, 3 minus 6, it will be x to the power -3, which will be there. So this is the best way. I believe that this is the best way. Just you need to be careful with the negative and positive signs. You can, of course, do it in a different way. Let me show you another way that you can solve it by. You can notice, ya shabab, here that this power, the whole power here is negative. You can flip this down, change the numerator to be denominator and the numerator to be denominator and so on. So it will be all to the power 3. But if you notice, this is also to the power 3. So all of them are to the power 3. So use the way that says a to the power n times b to the power n. It is just ab all to the power n. So this is what we will apply. So here we have 2a y to the power -3 b to the power -1x. If you look at this now, you can simplify. What you can do here, 2 will be cancelled with 2. 2 over 2 is 1. Y to the power -3 with y to the power 3. It is also 1 because y to the power 0 will be 1. Now what you have here inside, it will be b to the power -2, a. This is all what we have in the numerator. In the denominator, we have a to the power -1, no more a's. X to the power -2 with x, it is x to the power -1. And we have here b to the power -1, all to the power 3. Simplify, you have a and a here, b, and all of them are factors. So this will be b to the power what, ya shabab? -2 plus 1. And a will be 1 minus, it will be plus. And we have x to the power 1, all to the power 3. This one, we bring it up. This is what? This is b to the power -1, a to the power 2, x all to the power 3, which can be written as a squared over x all over b all to the power 3. Distribute now, it will be a to the power 6, x to the power 3 over b to the power 3, which is the same answer, but in a little bit longer way. So I advise you to use this method, but be careful with dealing with negative exponents. Be careful, shabab. We are doing this according to the laws of exponents. So we are using well-known laws, not our own laws. So be careful. Most of the mistakes, shabab, are coming because you are using your own laws that mostly they are not correct. Use the well-known laws. I'll give you also let's say 1 minute, I think, is enough for solving this. Easy quotient. You have here a number that you need to simplify. The mistakes, shabab, I have noticed that many of you, they did it in a wrong way. The mistakes are coming here from where? They are coming from the wrong application of the laws. For example, if you have here s to the power -1 plus t to the power -2 over 1 plus s to the power -3. Let's say like this. So if you did this, ya shabab, and bring this down and this up, so if you said that this is 1 plus s to the power 3, s to the power 1, this is not true, طبعا. Plus t to the power square. This is not true, ya shabab. If they are factors, if they are here, if you have a multiplication, let me say here t, and this will be t. If you have a multiplication, this will be correct. So when you have s to the power -1 times t to the power -2 over t times s to the power -3, this is correct. If you did this, if you said that this is t to the power -1 times s to the power 3 over s and t, or you can bring them down or up, whatever. This is true when they are factors, because you are just applying the rule that says that this is 1 over s. This is 1 over t to the power 2, and so on. So don't do it, shabab, this way, because look here. Let me show it in a clear way. I have here, the answer is 12, but if you have a shabab 2 to the power negative 1 plus 3 to the power negative 1, clearly this is 1 over 2 plus 1 over 3, which is just 5 over 6. This is the LCD 6, 3 plus 2 is 5. So this is 5 over 6. Now, is it correct if we said negative 1 plus 3 to the power negative 1 when they are in the denominator, when it is like this? Is it equals to 2 plus 3? It is not. This is 5, Shabab. And this is the reciprocal of this. So in fact, 1 over 2 to the power negative 1 plus 3 to the power negative, it is 6 over 5, the reciprocal of this one. How it show, you can show that? It can be shown easily. This is just 1 over a half plus a third. And this will be 1 over the half plus a third, it is 5 over 6, which is 6 over 5. So it is never. This mistake indeed is coming from applying this rule. You are saying that a plus b all to the power negative 1, they are a to the power negative 1 plus b to the power negative 1. This is not correct. Be careful. Similarly, a to the power negative 1 plus b to the power negative 1, when you raise them to the negative 1, it is not a plus b. So be careful. Don't apply the rules. This is what I'm talking about, your own laws. Ask yourself always which law I'm applying. Now let's see how to solve this, ya shabab. So here, again, negative 1 here is not in the base. The negative sign here is not. The base is 2. So this is negative 1 over 2 to the power 2 plus 1 over 3 all to the power negative 1. Now we are following, of course, the order of operation starting by what is inside the brackets if we can simplify. Now this is what? 1 negative. This is equals to negative 1 over 4 plus a third all to the power negative 1. What is this? Negative 4 plus third. It is 12. Now the LCD is 12. Now it will be negative 3 plus 4 all to the power negative 1. And this is equals to negative 3 plus 4 is 1 over 12 all to the power negative 1. Now it is about the reciprocal. What is the meaning of 1 over 12 to the power negative 1? It is about the reciprocal of 1 over 12. The reciprocal of 1 over 12 is 12. It will be 12 over 1, which is 12. Excellent. So if you did this mistake, I have noticed that some of you, they did what? They said this is just negative 2 to the power 2 plus 3. This is negative 4 plus 3. This is negative 1. This is not true, ya shabab. This is false. Be careful. You cannot distribute the power over the sum and the difference. Now, the scientific notation. What is the scientific notation? In fact, it is a mathematical way to have a short way to write the very huge numbers or the very small numbers like this. This is a very huge number, ya shabab. It is not practical to keep writing zeros like this. So what we will do, we will just count how many zeros we have here, and we multiply by 4. So this is 13 zeros. So it is 4 multiplied by 10 to the power 3. The idea is, you know, that 1,000, it is 10 to the power 3. 100 is 10 to the power 2. So we will use the idea of the powers of 10. 10, it is 10 to the power 1, and so on. For example, here, this is for big numbers. For big numbers, we'll multiply by powers of 10. For small numbers, this is very tiny number, ya shabab. Instead, of course, of writing these zeros after the decimals, we will just multiply. We will divide it, in fact, by powers we will divide it here by 10 to the power 24. But instead of doing this, we will write it as 10 to the power negative 24. طبعا, again, you can write this as 166 times 10 to the power negative 26, because here, how many digits after the decimal point? But we want to do it in this specific way. We want the numbers here that they are multiplied by 10 and its powers. We want them to be a number between, a real number between 1 and 10. And this is what is called the scientific notation. So if you have a positive number, a positive real number, for any positive real number x, it is said to be written in a scientific notation if it can be expressed in this way. A times 10. A is a real number between 1 and 10, strictly less than 10, greater than or equals 1. And n is an integer. It could be positive or negative integer. 1, 2, 3, 4, and 0, negative 2, negative 2, 3, and so on. Any integer. Let's have an example. Be careful about this. The scientific notation, in the scientific notation, this number must be between 1 and 10. Let's have an example. Look at this. By the way, don't mix up ya shabab between the comma. This is, we use this comma for Arabic, but in English we use this. So don't mix up between them. Now in English, this is for the decimal point. And this is in fact just a comma to separate between the hundreds, thousands, millions, and so on. Don't mix up between them. Now let me give you an easier example. 50,000. 50,000. Usually we, after each 3 digits, we write a comma like this. This is 50,000. We can write it like 5 times 10 to the power 4, or 50 times 10 to the power 3, or 500 times 10 to the power 2. All of them are the same number, the same value. But where is the scientific notation? Which one of them is the right way to write in the scientific notation? This one, the first one. Why? Because as we mentioned here, this number here, shabab, this number here that you multiply by 10 to the power is must be a number between 1 and 10. So this is the right one. Similarly here, again, let me remind you about, you remember we said that when you have 5, in fact 5, it is 5.000. The repeated zeros after the comma, after the decimal point. In fact, the decimal point is here. Don't mix up between it and between the comma. So in fact, here you have the decimal point is here. So we want to move it to be here, to be 5.6920, whatever. If you want to continue writing zeros, no problem. So this will be multiplied by what? 10 to the power what? How many digits? 1, 2, 3, 4. So it will be to the power 4. Check, because some of you, they write it -4. Is it 10 to the power 4 or 10 to the power -4? Are we minimizing or maximizing the number here? In fact, it is the same value. This number is, ask yourself, 5.6 multiplied by 10 to the power 4. Is it going to be 56,000? Yes. But if you did it this way, it will not be true. Now, this one is, you are dividing now. It will get smaller. If you multiply this, it will be 0, 0, 0. So it will be a bigger, smaller number when you multiply by negative power. So be careful when you write it in the scientific notation. It should make sense, yes, shabab. Check your answer. So here we are. Check, is this number between 1 and 10? So it is in the scientific notation. Look at this small number now. How to write it in the scientific notation? How to simplify it or to write it as a product of 10 multiplied to the power? How to do that? You can write it as 93 times how many? 1, 2, 3, 4, 5, 6. You can write it this way. It is the same value, but with negative, not with positive. If it is with positive, it is a very huge number, but it is a small number. In fact, you are here dividing by powers of 10. So check. Do you have now 6 digits? Yes, we have. But this is not a scientific notation, shabab. You can use this for simplifying the expressions, but not for writing them in scientific notation. To write this in scientific notation, what you can do, let me write this here for you, but just to compare what you will have with this. Now, to write this in the scientific notation, I will move this decimal to the right here, to be here. So it will be 9.3 times 10 to the power, how many digits we have here? 1, 2, 3, 4, 5. So this is by negative 5, by 10 to the power negative 5. Check your answer. Is it correct? Is it consistent with this? Yes. Because, ya shabab, here, in fact, if you look at this, if you want to go from here to here, just you can think about it in different way. You need to multiply by 1, but not any 1. You will multiply by 10 and divide by 10. So this is 10 to the power negative 6. It will be this 93 over 10. It will be 9.3 times, let me use times here, 10 to the power negative 1 plus negative 6. It will be negative 5. Here we are. You can go from here to here by the same idea. But it is easier, ya shabab, to look at the decimal. Just here, move to the right, to the left, according to what you want. let's take one more example about writing. If you have it in the decimal, if you have it in the scientific notation, how to write it in the decimal notation. How to do that? It is easier than example number 6. What you can do here is just you will move this. This is of course a very huge number. The power here is positive. So what you will do, you will move this to the right, and you will have 6, 9, 7. Now, how many decimal already moved here? 2. So and 0, 0 will have 7. So this is what you will have. We have moved this decimal point 9 places. 2 already are here, and we will add because of that 700. So now this is the number that we have. Similarly here, but now you will move it to the left in this way, because this is a very small number. So you already have a decimal digit here. You will move the decimal to here. So it will be 10 to the power negative 5. Then you will add negative 5 zeros. Look here. 1, 2, 3, 4, 5, 6. These are the 6 digits that we have. So we moved to 6 places because you multiply by 10 to the power negative 6. Do that practice by doing this several times, and you will be able to do it. Just think about how many digits you need to move to the right or to the left. I expect now that you will be able to solve this Ya Shabab recitation exercise. Here you need to do 2 things. Evaluate this expression and then write it as in scientific notation. Evaluating this is not difficult. Do it. So here what you have, no need Ya Shabab to write it in the scientific notation from the beginning. Just evaluate. At the end, think about this in scientific notation. So what is this equals to? This is 83. No need to write it as 8.3 from the beginning. No. This is 83 times what? 10 to the power, how many zeros? 6. Big number. Times, this is small number. What is this? This is 3 multiplied by 10 to the power 1, 2, 3, 4, 5. Just you will move the decimal to be here. And it will be 5, so it is negative 5. What is this? Now this is 83 multiplied by, let me write it cross, the same, 83 times 3 times 10 to the power 1, 6 plus negative 5. So what is this, guys? This is 3 times 3, which is 9, 3 times 8, 24, and times 0, it will be this number. This is the value. We did this part. Evaluate the following expression. Here we are. Now we need to write the answer. This is the answer. Write it in scientific notation. So how to write this in scientific notation? 2000. How to write 2000 in scientific notation? It is just 2 times 10 to the power 3. You will move, of course, the decimal. The same here. So this will be 2. Now the decimal is here because any integer, any number, any natural number, there is a digit here and zeros after that. So the decimal is here. You will move it to be here. 2.4. Why 2.4? Because I want it to be multiplied to be a number between 1 and 10. How many digits we move? 3. So this is multiplied by negative 3. Is that correct by negative 3, Ya Shabab, or not? So this is not true. Because if you have 2 multiplied by 10 to the power negative 3, it will be what? It will be 0.002, not 2000. We have here 2000. So it is by 10 to the power 3. Be careful about this. A mistake. But no need for writing the 0 here. Any zeros you will add here, they have no meaning. So you can stop here and write it like that. So it is 2.49. Don't approximate. Don't say 2.5. It is just, we need here to find the exact value. I believe, Ya Shabab, that we are done with this section, and this is the summary of section P3. It was a very short and interesting section. Look at the key terms. How many key terms, how many vocabulary you need to know from this section? Only 4. So this is what I told you at the beginning, Ya Shabab. Now, what is the most important part that we will still talk about until the end of the course is this part, the laws of exponents. This is common mistake. It is not allowed. You are not allowed to distribute the law over the sum and the difference, and you have many examples to show that. The scientific notation, this must be, of course, between 1 and 10. There are many solved exercises here for you, Ya Shabab, to practice. Please practice by solving, resolving them. Don't look at the solution. You have also some mini solved exercises with detailed solution. Again, the idea is do not write it in the scientific notation from the beginning. Simplify and then write it in the scientific notation. Exercises from your textbook. These are the recitation. We already solved 1 and 2. 3 is easier than 2, so you can solve it easily. I'm sure about that. I will leave it for you as an exercise, and you have here the choices. M times n. We already did a similar one here. This one. M times n. It is just 2 to the power -1 plus 3 to the power -1 times n is what? 36 times 10 to the power -4. It is important, ya shabab, to write the brackets here. If you didn't write the brackets, what you will do, you may multiply this by this. So this is wrong. So when you do that, you should, it is better, ya shabab, to start with m. What is m? Simplify m. M is a half plus a third. It is 5/6. This is m. Okay. Now this will be m times n will be 5/6 multiplied by 36 cross 10 to the power -4. And 36/6 will be 6. It is 5 times 6 times 10 to the power. Let me write it here because we need the space. So it will be 5 times 6 times, use a cross here when you have dot to avoid any confusion. What is that, ya shabab? 30 times 10 to the power -4, which you can write as 3 times 10 to the power 3. And you can write this as 0.003. You can write it this way. If he asks about the scientific notation, here it is. If he asks just about the value, the exact value, this is the best answer. Now, which one of the following is true? The following is true. This is the first one. Is it true or false? What is this? This is 3/2 all to the power 2, which is 9/4. So this is false. This is -5 to the power 4. This one is -5. It is 625, but this one is -625. This is, ya shabab, x to the power 6. So this is false. This is false. X to the power 6, not x to the power 5. Here, this is 2 to the power 3 times x to the power 12. So this is 8 times x to the power 12, not this. So he forgot to raise to the power. So which answer is the right answer, ya shabab, or which statement is true is the last one. Why it is true? Because what is this? Look at the half to the power -1. It is just the reciprocal of a half, which is 2. Similarly, 1/2 to the power -1. It is 1/2, which is 2 also. There are many solved exercises, ya shabab, here for you to practice. And what I want you to focus on is the problems here or the exercise that they are not solved completely. So it will be a good practice for you to check before looking at the answer. Try to revise the laws, to practice and practice. Thank you, and see you tomorrow, inshallah.